Hello, I'm Erkre, a Rocketry and student of a school previously founded by Elon Musk. And today I interviewed the BiSky Team University of the Basque country in the city of Bilbao. Could you please introduce yourself with your name?
Thank you very much for having us here.
And thank you for being here.
It is really amazing what you're doing with the interviews. I mean, with being such a young age and contacting people all around Europe, it's pretty awesome. So congratulations.
Yeah, thanks. It's actually easier to contact people than it seems.
My name is John Perez, and currently this year I am the team leader of BiSky Team, which is the rocketry team of the University of the Basque country. And as team leader, I am like the ultimate responsible of the team. And yes, that is what I do this year, more or less.
And I am Ignacio Mundarain, and currently I am the project manager and technical of the structure of BiSky Team. My responsibility is to manage the project, review the work of the members.
How many are you in your team, and what is your team's story?
We usually are around 50 students, more or less. History is, 2018, some students of the university decided that it was a good idea to create a rocketry team, because in our university there were other students' teams. For example, the Formula student team that they do cars, like racing cars. But there wasn't any team like about aerospace or rocketry, so they went on to create the team. And after contacting some professors and getting their assistance, the team started growing, and it has been going till this day.
With the first rocket launch, that was called Alpha, and that was a rocket made by 5 students, okay? And after that, we entered a lot of members, and we developed a lot of projects that we will talk about today.
How did you start your team in Spain?
It's a bit complicated, but not so difficult. You have to form a small team, like 5 members will be okay, and then do a research about what other teams are doing, and then you have to define a roadmap about what are you thinking about, what do you plan to do on the future. You have to look for professors or some kind of help at the university that are willing to help you, and start making some conceptual designs to show to the professors and to the sponsors that you are doing something. It's not just an idea.
For the part of in our university, there isn't a aerospace faculty, but it isn't really necessary having a specific aerospace faculty to do a rocketry team, because in the end, when you are designing a rocket, there are a lot of different parts that require different knowledge. You need mechanical, you need electronics, you need aerodynamics. So if you have mechanical engineers, electronical engineers, telecommunication engineers, you can combine that knowledge, and you will be able to build a rocket. So it isn't that necessary to have a aerospace. It is possible to do it in a university with an aerospace faculty.
How do you study in Spain?
I think that it is pretty nice. Also, our university is a public university, so it is pretty affordable. Also, you can study either in Spanish or in English, or here you can study too in Basque. That is a language that is from this part of Spain. Many different degrees that you can study here. You have mechanical engineering, industrial engineering, electronics engineering, telecommunications engineering. So there is a broad offer of degrees in here. In this part of Spain, there is a lot of industrial companies. So it is a pretty good place to study engineering, because afterwards there are a lot of working opportunities. And also when you are studying, you can also do like a scholarship in those companies, which is a pretty good option. In Bilbao, there is a pretty good nightlife. So as a student, that is also an important part. So it's a park.
There are a lot of opportunities to study abroad instead of studying everything here. We've got a lot of contacts with other universities. and we have a lot of labs to practice the. For example, fluid dynamics labs, material labs, physics, and so on. And they're also useful to apply them in rockets.
Are you in touch with other universities or alumni or space agencies?
We have a lot of alumni that are working on many companies that are related to aerospace agencies. For example, we've got some members that are working on Airbus and other companies which are our sponsors, as Sener, Satlantis, and so on. There are another ones who are making or designing some parts for airplanes.
Usually, it is a good idea to be part of a team like BiSky Team if you want to work afterwards in the aerospace industry, because in the end, you know a lot of people that have the same interests about aerospace, rockets, and these kind of things, and it's a good place to do networking. And also, some of our sponsors are related with aerospace, and they hire people that has been in the team. So yes, it is a pretty good idea to take part in a rocketry team.
How did you prepare for university? Which high school did you attend?
In my case, I attended the high school of my town. It isn't a special high school, but yes, that's mostly it. Also, before starting university, I already knew that I wanted to study engineering and that I wanted to work in space-related things. So you can always learn about these kind of things before entering university through reading books and watching YouTube videos and documentals. So I would say that is like the preparation that I had before university.
In my case, it was the same. I went to a high school here in my town, and it was not special of aerospace. I was so interested since I was so young on this sector, and I was always watching some films related to this, documentals, reading books, and that was my preparation also.
What are your goals and your strengths, and what is your roadmap towards space?
Our ultimate goal, as I think all the teams in Europe, is to get to space, which is a pretty ambitious goal. And our way to achieve that goal is through hybrid rockets. We have been developing hybrid rocket engines in a test bench. We already tested one engine, or M1, that was the first engine developed inside the team, and it's a paraffin nitrous oxide engine. We have in our development roadmap, we have two branches. One of the branches is the development of the rocket engines, because as it is a pretty complex system, you want to test it in the ground before you put it into a rocket. And in the other branch, we develop the rest of the elements of a rocket. We buy commercial rocket engines, solid engines. We develop the structure of the rocket, the aerodynamics, the electronics, the avionics, and these other parts that you can't really test them in the ground. So you need to launch rockets. And the idea is whenever the two technologies are ready to get put together, we will do a hybrid rocket with our own engine, and that's the way that we have chosen to get to space. Our projects now are Charlie, which is a rocket with a commercial engine, a big rocket, and we have M2, that is our next hybrid rocket engine.
To our strengths, I think that the strengths of the team are that we've got a good electronics team. We will talk about them later, but we have borrowed our electronics to some teams of Spain. And another strength is that we are so motivated and we work a lot together. We are always working, maybe one Saturday and at night, at 11 o'clock at night, we are working there on our rockets, and that are our strengths.
If someone wants to join your team, how could he?
We usually do 2 recruitment periods each year, one in September and one around February. And what we do is to send an email to the students of our university, because that's a requirement, being part of our university. We invite people to apply to enter the team. Once we have the applications, we do some interviews to the candidates, and we see which are the most the ones that fits the best to the team's needs. We don't really require having a broad knowledge of rockets beforehand, but the thing that we most require is being passionate and having motivation for doing rockets or for doing things and learning, because we think that that is the most fundamental requirement as someone that doesn't know about rockets but is passionate about it will put the hours to learn about it and to design the rockets and do the work. So that is the most fundamental thing.
We are all volunteers of the university, and we have to study and work on this team at the same time. And you have to be prepared to do both things at the same time. So the motivation is the most important thing about our project. And maybe I have to add that our ideal candidate be prepared to learn from his on its own, and to be so curious, to read a lot of books, to read papers on his own, and then to learn about them and apply those knowledge in our designs. Our candidates hasn't got any type of age limit. We take a lot of people of different ages, starting from 18 years, and the oldest is 25 years old. But because if someone with 30 years old comes to our team, that if he's studying, we will accept him if he's a good candidate.
What can someone learn in your team?
Obviously, you can learn about rockets because that is what we do. And you learn a lot of technical skills. We use different programs. We use different methodologies to design. And that's a good thing to learn as an engineer. But also a very important thing that you learn as part of the team is to work with a group of people, how to organize that group of people to do the work that you need to achieve a goal, which it seems like a pretty easy task, but usually those managerial aspects of a project are as complicated as the technical parts, because it is very difficult to manage times, money, and all these resources to get where you want to go. So you learn a lot about that aspect of engineering, about managing a team. And yes, it is also one part of engineering that maybe it isn't so much taught at the degree, because at college the professors maybe center their attention to more technical matters, and usually maybe an engineer when ends university doesn't have those skills that are very, very important. So I think that these things are the ones that you can obtain from being in a team like ours.
At the university, we study everything to calculate. For example, to calculate stresses and so on. But we do not really learn about how to design. Yes. And this is so important, because when you want to make some mechanical parts, for example, you have to think about how do you want to do the part, and the same as electronics and other things, other subjects. And this is so important because on the university, as I said, we only study how to calculate do the calculus and analyze them. And maybe this is a good option to learn about how to design. And also, this is like a company, so you will acquire new skills about how to work in a company, how to work with other people, how to maybe make some presentations and so on. And it's so good to learn that, and so useful.
How do you support and manage your team?
This is pretty complicated because we use a lot of methods since the start, and finally we got a method that it's working well. We are all part-time students. So we study, as I said before, we study and then we work on this, and we cannot spend all the time working on rockets. And we are organized with some chiefs of each department, and then we've got a project manager for each project. For example, I am the project manager of Charlie Rocket, and I have to be sure that every task is complete. I have to get all the resources to make the rocket, and so on. And we use a lot the software Trello. It's so good. It makes you the life so easy because you can see what everyone is doing and when they finish the task and so on. We all speak in Spanish and Basque in the project, and that's make that more easy. But if any foreign members enter to the team, it won't be a problem to speak in English with everyone.
How is the experimental rocketry community in your country?
4 or 5 years ago, there weren't many teams about rocketry or space-related activities, but in the last 5 years, there has been like a golden age of student teams in Spain. We are one of the oldest one, and yes, it is growing a lot the community here, which is a pretty good thing. We like rockets, and having more teams to compete with each other and defy whatever the others do. It's a pretty cool thing. So we are pretty happy with the situation right now with the space community in Spain.
Yes, we feel very optimistic about the future of the space industry here in Spain and in Europe in general, because thanks to new space, they are creating a lot of companies, startups, and student rocketry teams or space-related teams, and it will be more easy to enter to this kind of companies and this kind of sector that we in the past we saw like it's too far away from me, like NASA, it's not so accessible. And now, thanks to the new space era, it's like okay, I can enter to this sector more easy, and I think that people get more motivated about making rockets or satellites, and there are a lot of communities creating in Spain. We've got a Surtam community of the Spain teams, and we share all our experience, and we learn a lot about this sector with other teams thanks to this community.
I think that it is very beneficial having a strong students space rocketry teams, because like space companies grow in Spain, because maybe till today in Spain the space sector wasn't so big, but with having so many rocketry teams, there will be a lot of young professionals that are eager to start working in this sector, and this will make grow the companies about this kind of things here in Spain. So it is a pretty positive thing for the space sector.
I'm going to say for another team watching who might be watching this video, the launch initiative is an idea. that many teams could go into a spaceport and they could share the price of renting the spaceport, and they can all launch the rockets whilst paying less. It also could be a useful exchange of information between teams.
Yes, it's always cool to meet other Rocketeers also. It is an initiative that sounds pretty well. I mean, it is launching rockets, so that's always cool.
Yes, I think that it's a great opportunity to create initiative like that, because every time we want to launch a rocket, we see a lot of barriers, legal barriers, or site. We cannot find any good site to launch the rocket, or we have to pay a lot. An initiative like this would be great for every team.
Where do you launch your rockets?
On a mountain called Dima here in BiSky, and it's the unique site we have found, that the people of Dima they helped us a lot to find a site. And it's funny, that site, because maybe you go to launch the rocket and there are a lot of cows there in the mountain, or when we launched the Bravo rocket, our second rocket, we launched the rocket, and there we went to find our rockets, because we recovered all of our rockets, and we couldn't find that. People that were working there came with the rocket on their hand, and they were like, "Is this yours?" It's a funny site, but there are a lot of limitations of that site. We are looking for new ones.
Yes, especially to launch bigger rockets that go higher. The area that where they can land is much bigger when they go higher. So it isn't the ideal place to launch bigger rockets. But for now, for launching the rockets that we have launched that reach less than a kilometer, it is a good place, especially because the authorities are okay with us launching there. So yes, it's a good place.
I don't know if this would work, but an idea I had is maybe you could have like a remote controlled thing which ignites like a smoke grenade or something which burns and makes lots of smoke. So if you can't find it, you press a button and you see a lot of smoke coming out, and you know that's your rocket.
Yes, that's a good idea. For now, we have we have a method to find the rocket. We have GPS signal, which is always good. And also the rocket, whenever it lands, it starts bushing, making which also makes easier to find it. But yes, the smoke idea is a pretty good one.
How do you promote your team?
We use a lot of Instagram. You can follow us on Instagram, and we share a lot of videos and photos of our launches and our work and engine test and so on. It's so interesting. YouTube, where we upload some videos, and we make a lot of activities on our country. We go to Congress. We present our team in different events. We make our own event here in Bilbao called Space Week, where we invite a lot of companies and other student teams to share about their projects, and that is how we promote our team.
What are your plans for EuRoC?
We hope to participate in the next edition.
What is the technical review process that you use?
Normally, the veteran members, the old people of the team, review the work of the members, and also we've got the help of our professors at the university that are always happy to help us. They are so interested, and they are always proposing new projects, reviewing our works. And we also have a lot of sponsors that, apart from giving us some economic help for the team, they also help us a lot of classes and reviewing our work and helping a lot with calculus, design, and so on.
Once we have done the launch or the test, we also do a debrief. Each department does, puts in common the ideas of things that went wrong or that can be improved, and then in the veteran members of the team talk about all these things that can be improved and look for solutions to improve the team and the procedures and the designs. So that's not like the review of the. It is not like a previous review to the design, like it is an afterwards review to the design, but it is also very important because whenever we launch rockets and do engines, it is for learning and for improving our designs and getting better. So it is very important to do this task of looking back at what you have done and look how to improve it. So yes, that's other part of the design process.
Are you willing to join another rocket competition?
The biggest competition in the world is the Spaceport America Cup, but for the moment we are not considering going there, mainly because the economical or financial costs of having to send there the rocket, having to fly there the team, that's a big expense. And for the moment, we prefer to apply those resources in other areas, in designing new rockets or new engines, and also in going to compete there. So for now, the only competition that we are thinking about is EuRoC, that it is near, and so it is more affordable.
Yes, Spaceport America Cup will be a great opportunity to compete with other teams around the world. But as John says, it's too expensive and complicated because we have to ask for a lot of permissions to send our rockets there. And we are not interested at the moment at going to there. EuRoC will be a great opportunity also. We will try to join EuRoC for the next year. We will start designing our next rocket for EuRoC. We are in communication with teams here in Spain to try to make a competition here in Spain. And let's see how it's going. It will be a great opportunity to launch rockets here in Spain. It's so important to go to competition like this because you can compare your designs with the other teams and you can share your interest on rocketry with the other teams and meet a lot of people. So we are so interested in this kind of competition.
How do you finance your team?
We have a lot of companies that are sponsors of us. And they support the team in different ways. Some give us technical advice or some lectures about different subjects. Other sponsors give us different material or parts that we need for our rockets. And other companies give us money to buy for the parts that we need in the rocket. So with all this support, we can design our rockets. It is also important to outline that we have the luck. We are lucky because here in the Basque Country there are a lot of industrial companies, as I said, and there are a lot of companies that are interested in helping us. So that's a good thing for us.
Yes, in general, a lot of companies are interested to be our sponsors. At the beginning of the team, we've got like 4 sponsors, and it was like, wow, we've got 4 sponsors, and now we've got a lot of them. They are so friendly. They help us a lot. We have more more sponsors in Spain, not only in the Basque country, are helping us a lot, not only with economics, with technical support or giving us some materials or manufacturing some parts for our rockets. And we've got a lot of sponsors who give us licenses for calculus, like ANSYS, Altair, and so on. And in the past, we had a sponsor that was Kerbal Space Program, the game developers, and they were so friendly. We are thanks to them because they help a lot. Without them, this project wouldn't be possible.
How did Kerbal sponsor you?
Kerbal, yes, they gave us some licenses to play the game. It was like, I think, 3 years ago or like that we contacted them for a sponsorship, and they gave us some licenses. So it was more like a symbolic thing. It is pretty cool playing Kerbal Space Program. So we aren't going to say no to some licenses. We haven't continued with the sponsorship because the people, the members of the team that had the contact with the company left the team some time ago, and we lost that contact. But yes, it's a kind of an interesting story of the sponsorships of the team.
And they invited us to go to their company to see how they develop the game, and that was interesting. But as John says, we lost the contact. We will try to contact them soon. We had the idea to make some events on our university with that game, and would be great.
I think that Kerbal is one of the most fitting sponsors for a space team.
Yes, it is pretty accurate about the subject.
Do you play Kerbal Space Program?
In my case, I have played Kerbal Space Program. I played Kerbal Space Program before I got to study engineering, and yes, it is a pretty fun game, and you also can learn some basics about, mainly I will say, astrodynamics and how orbital mechanics work. Also, you can learn how staging is important in rockets. It is a pretty cool game to play. And also, if someone that isn't into rockets wants to learn a little bit about them, it's an easy and fun way to get to learn about rockets.
In my case, I have played a few times, like 4 or 5 times, and it's so interesting game. It's so funny, and on the team there are a lot of people that are continuously playing this game. We plan to make a competition here, but we will see in the future what we do. And it's too interesting to play this game. As John says, you can get basic knowledge of rockets.
How much do you build your rockets?
Talking about this like entire day. In our team, we try to design, manufacture everything we can. We use a lot of materials, a lot of methods of manufacture. For example, we make our fuselage, our own structures, internal structures, and nose cones made by fiberglass. We manufacture them on our university. We are improving our processes, and there are some parts that cannot be done by us. For example, if we need some special part that has to be machined, we cannot do them. So we contact with our sponsors and talk with them to manufacture those parts. We use a lot of different materials. We use 3D printed ABS or PLA parts because they are so light, and we use carbon fibers, a lot of aluminium, and our rockets our engines we use titanium, Inconel, and they are some advanced materials that help us to improve our design. We are using a lot of gluing because we think that is the best option to connect different parts. and soldering with our launch structure. We use soldering and steel a lot with our structures that are in that will be tested on the ground, because steel is too heavy to use that. We don't our soldering is not so good, and we prefer to test them on the ground. And maybe in the future we will use those techniques for our rockets.
A method that we use, that 3D metal printing. We have a sponsor company that does this kind of parts for us, and it is also an interesting method to manufacture complex parts of our rockets. So yes, we work with a lot of different methods for manufacturing.
How do you design the engine and the rocket structure?
We use a lot of software to design our rockets. We make our 3D CADs on CATIA. We make a lot of calculus using ANSYS, using Altair, and for the simulation of trajectory, we use a new software. John, you might remember the name.
Yes, Astos, and also we use for the simulations and doing modeling of the systems that go into the rockets. We use a lot MATLAB and Simulink, which is a pretty good software. We also use LabVIEW for data acquisition and this kind of matters. Whenever we design PCBs, the Avionics team uses Altair. There are a lot of different softwares that are used in the team, and it's one of the perks of participating inside BiSky Team, because most of these softwares we don't learn in university, and they are very interesting tools to learn, as they are used widely in the industry. So it's another learning that you can get from the team. We are working in our own model of the rocket trajectory in Simulink, a simulator that simulates the how the rocket flies, the velocities, accelerations, position of the rocket, where will it land, and all this valuable information that we want to know before launching the rocket. So it is one of the projects that is being developed inside the team.
And apart from all the software we are using, we make a lot of prototypes to test on the real life how our designs work. For example, we test a lot the recovery parts, because the simulation are not always good, and it's too difficult to simulate, or we cannot simulate those kind of things. We make prototypes, maybe the parachute opening of manufacturing. We have to test all of these things, and the engine, you can make an approximation, okay, on the simulations, but you have to test it on the real life. That's why we've got our test bank M1 and on the future M2.
I think that it is the best way to design something, to combine simulation software and real life experiments, because with simulation software you reduce the time that you need for the development and the money that you have to spend in doing a lot of prototypes. But also there is some real life data that you need to get in order to achieve a successful design. So you have to combine these two tools, prototypes and simulation, to get a good result.
Do you plan to use thrust vectoring, Airbrakes, or an attitude control system?
We have developed a prototype of Airbrakes that they are already manufactured, but we have to test them on the ground before we we use it on a rocket, and we have planned to develop a thrust vectoring. We did some kind of analysis, but we cannot use them on our rockets yet.
There's a lot of technology that has been developed in the team about this kind of subjects. A lot of members of the team that decide to do their thesis, their final degree project about something related with the team. There has been some projects about RCS system, a reaction control system. Also, what Ignacio said, that there has also been some research about developing thrust vector control. Also, in the team, we developed a prototype of Aerobrakes that haven't flown yet because it is like a pretty big and complex system, and we want to first launch simple big rockets and then complex big rockets. So we are going step by step, and this is something that we can add in the future. And for now, as for control and stabilization, we use the classical methods of passive fins, which it is simple, but it is also pretty robust, and it works without much development. So for the moment, our rockets have this kind of passive stabilization.
What kind of fins do you use and why?
We use passive fins that are fixed to the fuselage of the rocket. The fins that we have used till now have been trapezoidal fins, either from aluminium or fiberglass. These are the two materials that we have used for fins. And the reason to have chosen this design is simplicity, because as I said, it is simple, but it works well. And usually it is better to do a simple thing than a more complex system that has more ways in which it can fail. So for the moment, we are with fixed trapezoidal fins.
Did you develop a custom printed board, and is it an STM board?
We have developed our own avionics. It is a in-house made PCB. I will say that it is a pretty good avionics system, because we have used it in our rockets, and it has worked flawlessly. And also some other teams of Spain, another team of Spain has used our avionics for their rockets. So I will say that this is a sign that the avionics of BiSky Team is pretty good. Which sensors do we include in the avionics? We use an inertial measurement unit to measure all the accelerations and rotation of the rocket. Also, we used a barometer to get a measure of the altitude of the rocket. Yes. And also, it has a GPS to get the position of the rocket. And this is pretty much the sensors that we include inside the rocket. For now, we haven't put a camera into the rocket, but it is something that we are planning to do. And also in the future, we want to develop a second electronics that will be data acquisition electronics to put more sensors into the rockets. Because usually we launch rockets to get data about how they work, and in those complicated conditions of the launch, how the different parts work. So we are thinking about putting more sensors into the rocket to get data about the different elements. For example, putting strain gauges or accelerometers to get that information about different parts of the rocket.
Those sensors will help us to improve our designs and to verify our calculus. That's so important, because we can simulate a lot of things, but we have to verify that in the real life they are correct. And on our engines, we use a lot of sensors too, to measure the temperature, the pressure on different points of the engine, and to measure also the force that is giving us the engine.
I talked about the rockets, but I forgot to mention the test benches, where obviously we use a lot of different sensors to obtain pressure, temperature, flow rate, the thrust force of the engine, vibrations, strain in the combustion chamber, all this kind of valuable data that then is used in the designs.
How do you transfer data from the rocket to the ground?
We use a telemetry link to send the data to Earth, and also at the same time, it is all the data obtained from the sensors. It is saved in a SD card inside the rocket. It is pretty important because in the SD card save the data at a higher rate. It is also important to retrieve the rocket, but if the rocket can't be retrieved, we always have the telemetry data. In the team have self-made antennas and also sometimes like commercial antennas. And the frequencies that we used in the telemetry is usually either 2.4 gigahertz or 868 megahertz.
How did you build your launch rail?
It's made of steel, of commercial parts of steel, and some kind of parts of aluminium with some a structure called truss. Okay, so our launch rail is designed to be expanded. I mean, now the height of our launch rail is like 6 meters, but it's prepared to expand it to maybe 10 or whatever we need. That's why it was made by aluminium, by steel and aluminium, because the weight of each rocket will change, and maybe nowadays we are launching some light rockets, but on the future the weight will rise. So we think to make our launch to be useful on the future, and we can with our launch rail we can configure and determine different angles of launch. We've got a mechanism. Actually, it's manual. It will be changed to an automatic mechanism that rotates our rocket, and it will be very useful for the launches.
What recovery system do you use?
We design our own recovery systems. We have recovered our rockets with parachutes. That is like the most classical way to get the rockets back. And the difficulty in this system is how to do the deployment. In our case, in our last 2 launches in Anime de Sanio, we tried a lateral ejection system. The rocket, in this case, the rocket has a kind of a door in the side of the rocket, and whenever it reaches the apogee of the flight, activates some pyrotechnic devices and send the parachute out of this door. In the past, we have had some problems with getting it to work properly, the recovery system, but the 2 launches that we have done in the last year have been successfully recovered. We are happy because we think that we have a pretty robust and work recovery system. And for the separation mechanism, for the moment, we haven't worked on that because we haven't considered doing staged rockets, but it is something that can be useful to develop for the future. So we are planning to get to develop some kind of system of clap bands or something like that to yes, to have it available if we need it in the near future.
The recovery system on the actually it's made by parachute because it's the simplest method, but it's not so simple. We have to test it a lot, and on the future we will use our own airbrakes, but it's the conditions on the sky are not determined, and we cannot expect some kind of conditions on that there. So we have to test them a lot and go step by step, verifying our designs. But on the future, we plan to use our airbrakes after they are tested on ground. We will test the airbrakes. At first, we will use the airbrakes with a parachute, and we will see how it works. And on the future, I think that we will change our recovery system to some complex one.
What payload do you put on your rockets?
We don't use payloads. We have to test our rockets to be safe, and on the future maybe we will implement more payloads on some kind of scientific experiment. I think that a lot of people is interested in getting some data and make some experiments on the space. And when we reach the Kármán line, we maybe send there some experiments or payloads. At the moment, we are getting data with our electronics that will be useful for us, but we are not launching any CubeSat or anything like that.
We don't plan to design our own payload. One of the goals of the team was to open our rockets. One of the research teams of our university is interested on gathering some data that can be done with our rocket, so they can put their experiment or payload in our rocket, and this way we launch a rocket, which is what we want, and also we get some useful data for some team of the university. So that is one of the goals in the future. But as Ignacio said, we first want to have a pretty reliable system, which we know that we will work flawlessly, and then we will think about putting payloads or experiments or whatever it is interesting to implement.
Do you want to announce something for next year?
First, we will like to make our altitude record with our rocket called Charlie. We would like to reach the 3 kilometers barrier, and that will take place in September probably. It will be a challenge for us because, as John says, we only have reached less than a kilometer, and we are on the next year we are going to launch 2 rockets. Their name is Atlas and Hermes. Okay, and Hermes will break the barrier of the sound, and that will be a challenge for our designs. It will be so light. I think that it will be like 6 kilos, the entire rocket, and it will be challenging to design and get so light parts for the rockets.
Also, we are planning to light our second engine, not soon. It is M2, a 5 kilonewton hybrid engine, which is a big step from our previous engine, M1, which had like 300 newton of thrust. And we have been a long time developing the engine, not only the combustion chamber, but all the auxiliary equipment that is necessary, like valves, instrumentation, the tank to contain the oxidizer. So it has been a long project, and we are eager to see it come to life and and having it tested.
What are your personal future plans?
Currently working on a company designing some structure for satellites called Satlantis. There we make some micro payloads for Earth observations. On the future, I would like to work designing some mechanisms and structures for rockets, and it will be a great opportunity to work in SpaceX. Would be so interesting, or any kind of company like Aerospace, Avio, and so on. It would be a great opportunity. I would like to work in one of those companies or in a startup. It's a good opportunity to work in a startup because people there are so motivated, and there are a lot of exciting projects. And I would like to work in aerospace sector.
In my case, I still haven't started working, but I obviously want to work in space-related activities, preferably in rockets. Yes, my plans for the near future is to, whenever I finish the master degree, want to start working in some company related to this matter and get some experience. And also about the startups, I have thought about starting a startup of something related to this, but it is pretty difficult. So I think that my near future plans are to get some experience in the sector, and then we will see from then. But yes, obviously, I would like to work in SpaceX or here in Airbus, Ariane, something like that, developing rockets. That is the one thing that I like.
Do you have any advice to young rocketeers?
If you want to learn about rockets and you are still not in university, I will say that it is a good option to look if there is some rocketry club nearby your town. Is a good way to start doing things and experimenting with rockets, and you can learn a lot of things. And obviously, if you are already in university, like is my case, I will say that if there is a rocketry team in the university, go for it, because it is like a very good opportunity to do rockets. Because obviously, if you like rocketry, you can do rocketry yourself with your own resources, but the resources of one person are pretty limited. So being in a team like BiSky allows you to learn about, to do like bigger projects, and that is a pretty cool thing to do, because you can design bigger things and rockets that reach higher. So yes.
Here in Spain, we are helping other teams to start. We advise them a lot. We try to give them our knowledge, and I think that the best advice that we can give to a new team or rocketry team is like, it's good to be ambitious. It's good to reach the space, but you have to be prepared to fail, to delay some projects, and to delay your main goal. You cannot pretend to reach the space in 3 years without doing anything. Maybe without doing your own engine or doing your own rocket, your entire rocket. So that's my advice for the new rocketers.
What are your favorite space movies?
My favorite space movie, which is Interstellar. I think that many of the people that will listen to this video will like Interstellar too.
I agree with you. Interstellar is the best movie, and the Martian would be a great movie too. It's wow, like being an astronaut.
Yeah, I do agree. Interstellar and The Martian are good. Also, Star Wars is good. It's not as realistic, but it's good also.
Yeah. It's good.
Do you have any questions for me?
How it is like to study in the Elon Musk's school?
It's pretty good. It's definitely more advanced than well, that's for sure. I don't know if it's the most advanced school in the world. I'm not sure. Probably on university is more advanced. But it's pretty advanced for the children who are there.
And what are your plans in the future? You want to work in the space sector, or what do you want to work in?
So I'm really interested in rockets. So my future plans are to build a space company. I'm not sure how I will get there. Yeah, I don't know if I'll get investors or I'm going to start another company and then you sell it and use that money to start the rocket company. I'm going to make a space company, hopefully.
It is pretty ambitious, but if you know that you want that, go for it.
That's a great idea. Do you personally meet Elon Musk?
No, so it's the school was okay. Elon Musk created a school for the children. That was Ad Astra. Then Elon Musk moved to Texas because of SpaceX, and there was COVID. So what was Ad Astra went online, and it's now Astronova. So it's practically the same school. It's the same teachers. They teach the same stuff, but Elon Musk doesn't have anything to do with the school anymore.
Would you like to come to our next event where we launch a rocket or we fire our engine? You will be invited.
I think it would be interesting. I don't know if I can get there for. If I can, I think it would be interesting to see a hybrid rocket engine or a solid rocket engine flying.
Yeah, it is a pretty cool experience. So
Yes.
if you anytime going to Spain for tourism or a visit, you can visit us and we will show you around our rockets and our engines and the things that we have in our facilities.
And what are your plans with your YouTube channel?
In this moment, I'm doing interviews to learn, and then I'm publishing them on YouTube because it's nice. I can attract other teams. I can get contacts, and it's nice having a YouTube channel. Thank you a lot for joining me. And if you're someone watching, please like, comment, and subscribe on my YouTube channel.
Thank you, Etto, for inviting us to the interview. It was a pleasure to be speaking with you.
A pretty extensive interview. So very good work, Etto. And thank you very much for having us and let us speak a little bit of our team. That is always nice.
Thanks to you. Bye.
Bye.
Bye.